There is a complete system of symbols that I've been gathering from the ancient world, and they are, I took the math from today and I put it all in this symbolic form. The symbols are 1 through 9. This is not numerology, and it's not any math that you've ever done or that I ever did before. It's different. And these symbols are as valid today as they were back then. I think that people back then in the ancient world thought more symbolically than we do today. A fascinating thing happens when we put all of our numbers into 1 through 9. We reduce all the numbers into a single digit, consistently, perfectly. The main principle is the concept of all life being connected in an individuality and at the same time a duality. The first two symbols are, of course, 1 and 2 that I use. The 1 is an individual uniqueness. The 2 is being in a collective of all life. Now, this system, as I said, is 1 through 9, 9 being the key to the whole system. 9 being the placeholder that it is, has certain anomalies and peculiarities. And for example, any number added to 9 results in that number or numbers. When we reduce, all of this is in reduction, reducing all the numbers 1 through 9. For instance, if we try to add anything to 9, we get the number we started with anyway. For instance, 9 plus 4 is 13. 3 and 1 is 4. If we add the numbers together, then we can get a single-digit number. 9 plus 7 is 16. 6 and 1 is 7. That's how we reduce. Now, this gets easy because we can't add anything to 9 in this system. We can take 9 out of every equation, and we'll come up with the same single-digit answer. 9 plus 28 equals 37, and that equals 3 plus 7 equals 10. Take away the 0, and that's 1. If we eliminate the 9, 2 plus 8 equals 1. If we have just 2 9s, by the way, just 1 9 becomes a regular number in that equation. So we can not only eliminate the 9s in every equation, but here's the first peculiarity. We can eliminate any 2 digits that equal 9. 8 1, 7 2, 3 6, 4 5. In this equation, 9 plus 8 plus 1 plus 5 plus 7 plus 6 plus 2, we can take out the 9, the 8 1, the 7 and the 2, and all we have left is 5 and 6, and that equals 11. 1 and 1 is 2. If we don't take out those numbers, we have 9 plus 8 plus 1 plus 5 plus 7 plus 2 plus 6 plus 2, and that's 38, and that equals 11. 1 and 1 is 2. We get the same single-digit result every time. Now, when we subtract in this system, we don't use negative numbers because we're only using the whole numbers 1 through 9. So we have to consider what we're going to do with 0. When we multiply, multiplying is incredibly informative and fun, and we get all kinds of information from it. One of the things that we really get used to looking at in this system is mirror imaging of our numbers. Look at 9 times 3 equals 27, and that equals 2 plus 7 equals 9. Well, 9 times 8 equals 72. You see how 27 and 72 mirror image each other? And that equals 7 plus 2, and that equals 9. Multiplication is intriguing. And when we divide, we do reconsider. Here, I define another number for our infinite number. And you will see the validity of it. You'll see why. 3, 6, and 9 have an affiliation. They have a connection. They connect one to another. 3 plus 6 equals 9. 3 plus 3 equals 6. 1/2 of 6 is 3. 6 and 6 is 12. And 2 and 1 is 3. 6 times 6 is 6. And that equals 9. 3 times 3 is 9. They always point to each other. And there are other anomalies with 3, 6, and 9. And one of them is, this is kind of fun, 1 plus 2 plus 3 equals 1 times 2 times 3 in this system, because they both equal 6. If we do 3 plus 4 plus 5, that equals 12, which equals 3. 3 times 4 times 5 equals 60, which equals 6. 3 and 6 always point to each other. 6 plus 7 plus 8 equals 21, and that equals 3. 6 times 7 times 8 equals 336, and that equals 3 and 3 are 6, plus another 6 equals 12, and that equals 3. 1 plus 2 equals 3. You see how we get the 21 and the 12? These are very important numbers here. Very important mirror image. It's the basic concept. 8 plus 9 plus 1 equals 18, and that equals 9 because 8 and 1 is 9. 8 times 9 times 1 is 72, and that equals 9. Yeah, the numbers come out the same with 8, 9, 1, and 1, 2, 3. I decided to put this in a form that I was used to, and that is, I wanted to put all the addition in front of me and take a look at it and reduce every number. And I did that here. I put all the ones tables 1 through 9, and then all the 2s and 3s and 4s and so on. I laid them out in front of me. And the purple numbers here are the reduced numbers. And you see every number is used. There are no repetitions of numbers. It comes out perfectly. Every number is it might be in a different order, but it is always there, and the numbers are never, there's nothing ever eliminated. Therefore, we always get the same numbers. They might be in a different order. So when we first add them up, if you look at the ones, the purple numbers, it all adds up to 45. And it's always going to add up to 45 because, as I said, we're using the same numbers. Nothing is eliminated and nothing is repeated. Take a look at the unreduced numbers, the sum of those, and that's 54. This is the mirror imaging that comes up all the time. Let's take a look at some of the other sums. The 2 table, has a sum of 63. The 3 table has a sum of 72. The 4s, 81. The 5s, 90, and so on. Did you guess it yet? They're all members of the 9 times table, which is perfectly logical. 9 is the last digit of 1 through 9. So these are going to be in digits of 9. But let's take a look at that 9 times table. This is intriguing because the 9 times table is perfectly symmetrical. Take a look at the 9 times 5, and that equals 45. The 9 times 6 equals 54. Now let's expand out. 36, 63, 27, 72, 1, 8, 18, 81. They are perfect mirror images of each other, and they define the numbers 4, 5, 3, 6, 2, 7, 1, 8. These are the same 2 digits that you can take out of all your addition equations, and you'll get the same reduced answer. I decided to do all the multiplications tables because the 9 times table, that got me into multiplying. So I put them all out in front of me just like I did the addition tables, and then I realized these numbers 8, 1, 7, 2, 3, 6, 4, 5, they go together. The system is perfect. It always redefines itself, and it never deviates. There's never an accident. There's nothing that is chaotic or out of place. Everything is always in perfect order when you do this math. And that has quotes around it, I understand. Okay, so the 1 and the 8 tables go together because, okay, read down the answers of the 1s, and I'll read up the answers from the 8s. Ready? Read down the answers from the 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. They're the exact opposite. They're backwards in the 8 tables. It's 9, 8, 7, 6, 5, 4, 3, 2, 1. Now let's go to the 7. And these are the only 2 tables that'll do this. The only ones that you get these sums. Now let's go to the 7 and the 2. You read down on the 2 table, and I'll read up. 2, 4, 6, 8, 1, 3, 5, 7, 9. I have the same thing in the same order backwards or upside down or in the other direction, whatever you want to call it. The 3 and the 6, as I said, the 3, 6, and 9 are very special. They have their own system, which turned out to be a perfect system here. We have the 3's table and the 6 tables. They keep connecting with each other. The sums all the way across. 3, 6, 6, 3, 9, 9, 3, 6, 6, 3, 9, 9, 3, 6, 6, 3, 9, 9. Nothing's ever out of place. Take a look at the sums of those numbers, and if you remember correctly, the sums of 1, 2, 3, 4, 5, 6, 7, 8, 9 is always 45 because we're always using the same numbers. But here we're not using the same numbers. All the rules go out the window with the 3, 6, 9. It has entirely different rules, but it works. It's perfect. The sum is 54. Instead of 45, it's the mirror image. If we look at the 4s and the 5s, the 4s and the 5s they point to each other too. This time you read up from the bottom of the 4s to the top, and I'll read down down the 5s. 5, 1, 6, 2, 7, 3, 8, 4, 9. The same order backwards. Okay, now if you can grasp this, we're going to count to see how these 2 tables interlock. there's a 1. The 5, 1, it's the 4 times 7. This is the 1 from that, 28. Okay, we're going to start there and we're going to skip every other number. 1, skip up to 2, skip up to 3, skip up to 4, skip over to 5, skip 6, skip 7, skip 8, skip 9. Now let's go back and fill in the skips. 5 times 2 equals 10, so that's a 1. Can you see that in the 5s? 1, read down, skip to 2, skip to 3, skip to 4, skip to the 4s, skip to 5, skip to 6, skip to 7, skip to 8, skip to 9. They fit together like a glove. Now, just to check our, quote, math and see if we're doing it right, let's look at the sums across these connected numbers, the 8, 1, the 7, 2, and the 4, 5s. The 3, 6 we know connect. Okay, so the 1 and the 8 table. Let's look at the reduced sums. 1 times 1 is 1. 8 times 1 is 8. 1 times 2 is 2. 8 times 2 is 16, which is a 7. As we continue, 3 goes to the 6, 4, 5, 5, 4, 6, 3, 7, 2, 8, 1. And the 9s are on the outside. Now, every table this works. Even when they skip, let's go to the 2 and the 7. 2, go across to the 7. 4, 5, 6, 3. I'm crossing the tables now. 8, 1, 1, 8, 3, 6, 5, 4, 7, 2. You see how they keep redefining the system. The system is a whole, complete system. It never deviates. Let's do the 4s and the 5s. 4, 5, 8, 1, 3, 6, 7, 2, 2, 7, 6, 3, 1, 8, 5, 4, and the 9s. Our magic key in this system seems to be 8, 1, 7, 2, 6, 3, 4, 5. It is a peculiarity that there are no duplications in the system. Nothing's repeated aimlessly. There are only 4 duplications in this whole entire system of numbers. And that is, guess where? In the 4 and 5 table, in the 2 and 7s, and the 1 and 8s, and the 3, 6, and their mirror images. So 45 times 6 and 54 times 5 are both 270. This never happens except in these 4 times. 27 times 8 and 72 times 3 equals 216. 18 times 9 and 81 times 2 equals 162. And 36 times 7 and 63 times 4 equals 252, a nice palindrome. These are the only duplications you get in the whole entire system. Again, it's redefined the 8, 1, 7, 2, 3, 6, 4, 5. Okay, now what do we do with 0? Uh-oh. When we subtract, don't look at the green numbers yet, you might get confused. When we subtract, we come up with 0. 1 minus 1 equals 0. Very first thing when we start. But we don't have 0 in this system. It takes it out of the system because we're only dealing with 1 through 9. So I tried several things, and I finally put the 9 where the 0 goes, and that took out the zeros. But when you put a 0 in, you get also repetitions. Look at the 2s, 1, 0, 1. So what do I do with the repetitions? Well, the 9 has the ability to change the numbers in one direction or another to the numbered pairs. 8 goes to 1, 7 goes to 2, and so forth. Okay, 8, 1, 7, 2, 3, 6, 4, 5. We're dealing with the same pairs. Let's look at a table where the 9 is in the middle of the table, so I can show you what I did. Let's take the 4 table. If we read 0, 1, 2, 3, and then 0, 1, 2, 3, 4, 5 down, if we put a 9 where the 0 goes, and then in the numbers where we're reading down from the 9, we turn them over to their numbered pair, and it works out perfectly. All this is perfect logic, I understand. But this 8, 1, 7, 2, 3, 6, 4, 5 is, and with the 3, 6, 9 are just intriguing how this whole system works. So that the reduced sums in the 4 table are now 3, 2, 1, 9, 8, 7, 6, 5, 4, and it always seems to wrap around. It doesn't go up any further than 9, and it doesn't go any further than 1. You can wrap all these tables around. Let's look at the 5s. This is what kept me going on this subtraction, because I saw that the 5s that are in blue here, if you look at the unreduced sums, 0, 1, 2, 3, 4 in one direction, 0, 1, 2, 3, 4 in the other direction, well, that's perfect symmetry. And I knew there was perfection in here somewhere. So it comes out if we put a 9 where the 0 goes, and then we change the numbers in one direction or the other to their numbered pairs, we get a complete system which wraps around, and there's nothing eliminated and there's nothing repeated. So if we read from the top, 4, 3, 2, 1, 9, 8, 7, 6, 5, of course it's all perfect logic. Now I made a grid because I just wanted to look at all these answers I got from the subtraction tables. And if you look at the upper left corner where the 9 is and look down diagonally where all the 9s are, that makes a complete line, right? As they all do. All the 8s do that, and all the 7s and all the 6s, and on the other side, all the 1s, all the 2s. Every number goes to its numbered pair in this grid. Also, if you look in the lower left corner and we read diagonally to make an X, 1, 3, 5, 7, 9, 2, 4, 6, 8. Where have we seen that before? The 7 and the 2 times table. Division is also revealing how to work this system, and in the division we actually do redefine infinity. Now, there is a concept here that I've gone over in quite detail in one of my other videos. It's the 1 and the 2. How no number it stands alone all the time. It's an individual number and a uniqueness too, and a wholeness. It's a whole number and a unique number. But it also connects with other numbers, as do the 8, 1, 7, 2, 3, 6, 4, 5. Now, the 1 and the 2 are a connection concerning the 1, the individual, the singularity, and the creation of the 2. 1 can't do without the 2. In creation, 2 can't do without the 1. And so we have this, the 1 is in the 2, and the 2 is in the 1. There are really no numbers that stand always alone. And here, the 2 in the lower right, it's kind of in the center, table of the 2's, in the division table, this is the perfect symmetrical one in division. And because you can see the 2 divided by 2 is 1, and the 4 divided by 2 is 2, and the 6 divided by 2 is 3, 8 divided by 2 is 4, and then 1 divided by 2 is 5, 4. See, we do the 9 divided by 2 is 4, 5, and the 1 divided by 2 is 5, 4. Isn't that intriguing? The 3 divided by 2 is 1.5, which is 6. The 5 divided by 2 is 7. 7 divided by 2 is 8. Get that? 3.5. And then the 9 again. Now, what gives us the key here to the infinite numbers? Well, it's not the 8. The 8 holds the symbol for the infinite numbers. But look at this 7 division table. It always comes up with numbers that are the same. Look at 2 divided by 7. And you get 0, of course. Point. Now that 0 is a 9. And that 9 has the capability of turning these numbers to their numbered pairs. So I have both sets of numbers here. Well, this reads 4285714. Excuse me, 285714. I read the 3's. 285714. And that is our infinite number. 714285, and all of their combinations of numbers. If you do the 1 first, 1, 4, 7, 8, 5, 2, and they always go to their number pairs, but it's the family number group that I'm talking about. So, but here it's always 714285. And instead of an infinite number going as far up as possible, the numbers never stop. You stop at 6 numbers and it wraps around. Because if you have the system, it works around in an 8 figure, and it is constant, never ending. It is infinite. The number is 714285 here, and the 8 symbol defines that. Whereas every single table in here, every single number in the 7 table, it has in it those numbers which wrap around. 428517 is the 3 divided by 7. Now, 28571, it wraps around to 4. Look at the 4 divided by 7. 5714285, it wraps around. Look at the 5 divided by 7. 285714, perfect. And let's look at the 6 divided by 7, and that's 714, and then the 2 wraps around to the 8. Okay, 7 divided by 7 is the only whole number we get in that table. And every time we're looking at the 7s, anything to do with 7, we're always getting an infinite number, except for 7 in itself. And that's a whole number 1. Now, 8 divided by 7 is 714285. And the 9 divided by 7 is 285714, or 185714, which the 1 can switch to the 2, and it does that in the ones too, the 1 divided by 7 too, because the 9 does that. It switches the number. The 1 and the 2 can switch. The 1 and the 2 are very elusive. You find them in each other and they define each other. Sometimes in this math, the 1 actually defines a 1 of something, or a 2, a duality of something. It's not a number. We're not counting here. And I think it's really fun that this is a whole, complete system of symbols. This is the language of the ancient world, which, if we thought more in this symbology of a system of perfect symbolism in a language which we can all understand, we can unify and simplify our world, and we can create peace and freedom and love in life's experience.